Hi, everyone, and welcome to today's online talk, Architecting Microservices Applications with Instant Analytics. Thank you for joining us today. I'm Lisa Sensmeyer on the Partner Marketing team at Confluent, and I'm excited to be joined by our speakers, Tim Berglund and Rachel Pedreschi. Oh, Rachel, I just butchered your name. I apologize for that. Pedreschi. I'll keep trying.
Pesky, but close. It's cool.
Well, I'd like to kick things off by introducing our speakers today. Tim Berglund is a teacher, author, technology leader with Confluent, and he serves as the Senior Director of Developer Experience. He can be found speaking at conferences and all over the world. He's the co-presenter of various training videos and the author of books, blogs, and podcasts. He's our Kafka and Confluent platform expert on the call today. Rachel Pedreschi, I kind of got it better, but I'm not so sure. Rachel is the worldwide director of field engineering at Imply, a self-proclaimed big data geekette. She has over 20 years of high performance experience with databases and building data warehouse strategies. She's a Cassandra, Vertica, Informix, and Red Brick certified DBA, and our Druid and analytics expert today. All right, with that, I'm going to turn it over to Tim.
All right. Well, thank you, Lisa. I want to give you a picture of Kafka and the Confluent platform as an ecosystem. There's a lot of people who are even running Kafka in production who I find don't really have the broadest view or as broad a view of the platform as they should. So I'm just going to walk you through a little bit of an introduction, and we'll start at the beginning, and we're going to build up the important components of the platform, and I'm going to end with that platform in place. I'm going to give you an idea of the kinds of systems I think you should be building. Now that's a broad statement, but I'm going to give you a vision of the software architecture that kind of Kafka implies. And then, hey, Rachel, I said imply. After that, I'll hand over to Rachel, and she'll talk about Druid, and then we'll see how these two things go together. All right. Well, the world is a place where things happen, right? And we write programs, and those programs process events. Now, that is potentially a very tendentious way to describe software and convenient for the guy who's talking about Kafka, but really, if you think about it, it's true, right? You build applications, and those applications take input. That input takes the form of events. And so Kafka is a system for organizing those events in ordered logs. And we model those events as key value pairs. And when they happen, we put them into these things called topics, and they're kept in order, and they're kept immutably. When an event is produced into a topic, it can't change, and that's just like events in real life, right? Once a thing happens, once you've said those words, maybe in the heat of an argument, you can't make those words not be spoken. You've already said them. Events happen, and they're immutable. Same thing with events in Kafka, right? These are immutable things that we store in these ordered logs. They're immutable, and they're durable. Kafka is not a queue where the presence of an event in a topic is somehow ephemeral. It's really a thing that is there to last and there to be stored for a defined period of time. That period of time could be infinity, it can be a day. You can turn that knob, but these things are durably recorded in logs. And how do they get there? Well, you write a program that puts them there. That program's called a producer. And at the very, very lowest level, those of you who are developing with Kafka or running Kafka in production, you know this. If you're not new to Kafka, you could probably assume this. It's a library, right? And there are language bindings for various programming languages: Java, Python, Go, C, C++, languages of the .NET platform. Those are all Confluent supported libraries. And this is just a program that puts messages into topics. And as you can see here, those topics, of course, are scalable, right? It's not just a situation where one broker, one machine in the Kafka cluster has to manage the whole partition. I can split that partition up among many brokers, which gives Kafka its horizontally scalable properties. So if you come to Kafka thinking, hey, this is a snazzy new message queue, and it's like enterprise message queues I've used before, it really isn't. So the partitioning story is a part of what differentiates it. And the durability story. These are not really queues, these are logs. Things last potentially forever, these immutable events. You can store them for as long as you need in logs. Of course, we've got to read things out. It would be no fun if it were a write-only system. Hey, that's a good idea. Maybe those of you who are operating it, I guess administering a write-only log would probably be a lot easier because it doesn't matter if it stays up. But of course, it's not. You read out of it, right? And the consumer is a program that you write that reads from a topic. Another super important thing about Kafka, just from an architectural standpoint, and Kafka's kind of neat because there are these few little decisions that it makes. One is that events are immutable. That's not really a decision Kafka makes. That's just kind of a fact of the world. But because events are immutable, because messages in Kafka are immutable, the architectures we can build on top of Kafka just get a lot of desirable properties. Also, because the act, when this consumer reads from a topic, it's not really consuming the message, it's not destroying it. It stays in the topic. That topic is a log, and you can read all those messages as much as you want. Which means what? Which means you can have more than one consumer. I'm showing 2 here, but 2 is not the limit. Once I've got a log, and just think to yourself about your business and the problems you're solving, the domain you're in, what kinds of things do you put in topics? It's a great question. And you know the answer. Well, there's probably more than one program that you could write that would be interested in processing that data. Right, so any number of services can grow up around a topic, even services you haven't imagined yet. Other teams can come up with reasons for writing consumers, and they can read that same data. Very important. We can also scale consumers. If you've got a lot of work to do or just a high volume topic with a lot of messages being written to it, you can deploy multiple instances of that consumer application. That means you spin up a new managed server in the cloud, you add a new container, whatever it is, however it is you deploy your software, just deploy that same image again, and the cluster will fairly distribute partitions to those new instances. You can scale out your consumers without having to do anything. That's actually an automatic feature of the platform. Now, this is cool. This is a very, very, very good foundation for building the kinds of systems that we as developers and architects are called upon to build these days. And suppose you do that, right? You say, hey, I heard this guy, Tim, and I listened to him for 5 minutes on a webinar, and I was totally persuaded, and I went and I built stuff with Kafka. And now suddenly you've got all these systems integrated through this scalable event streaming platform. The problem is those integrations, those arrows are going to be a lot of work. Right now, I'm talking to my NoSQL database, and I'm talking to S3, and I'm writing to Elastic, and I'm doing change data capture from Oracle and DB2 and all these things. Those arrows are a lot of work. So the Kafka as an ecosystem gives you a framework called Kafka Connect. Kafka Connect is a client program that you run outside the cluster. It's this little scalable framework that you run. You actually deploy on its own servers, and then you can install connectors into that Connect cluster. And Confluent platform includes a number of connectors, and let me tell you, that is an ever-growing number of connectors. As the guy who is partially responsible for making sure the developer community is enabled and up to speed on how to use those connectors, I can tell you it is a library of connectors that is growing very quickly. There's a lot of them. So the things you'd want to interface with, Kafka Connect and the connectors of the Confluent platform are there to help you do that declaratively, so you don't have to write a bunch of boilerplate code. Another thing that happens, again, so suppose you took my first 5 minutes and you ran off and you started building things, you'd find that these consumers get interesting. Things happen in there. Like you want to compute aggregations over data in a topic, or you want to take data in one topic and join it with data in another topic. You want to enrich a topic with another one, or with a lookup table or something like that. That happens all the time. And so Kafka gives you a Java API called Kafka Streams that does all that. If you just went and you built those consumers yourself using the low-level consumer API, you'd have to write a bunch of just framework code. And it's fun. If you're a developer, it's fun stuff to write. But if you have a responsibility to a business to deliver value to customers, you get in trouble for it. So Kafka Streams is a Java API that provides all that framework for you. The kinds of functions that just emerge in consumers when you're building applications on Kafka are things that are answered by Kafka Streams. Kafka Streams is, like I said, a Java API, and so I'm obviously not going to walk you through all this code right now, but it looks something like this. It's a pretty modern, functional, fluent API. So if you're a Java developer or you play one on the internet, then you'd be reasonably pleased with the way this API is put together. And it does so many things for you that you would otherwise have to code yourself. And there's a lot of complex problems, distributed systems problems that it's solving that you probably don't want to be in the business of solving. So Streams, super cool thing, definitely worth checking out. Also, there's a whirlwind tour of the platform here, so I just really want to give you a taste for all of the pieces. If you're, say, not a Java shop, it's totally okay. We can still be friends if you're not. Or if, say, you have some stream processing to do where you're just computing some real-time aggregation over what's in a stream, and like you know ahead of time, well, I need to compute this aggregation, it needs to run. It's not a part of any other microservice or anything. I just want to ingest this topic, compute this aggregation, spit it out to another topic. We have a language called K-SQL for that. Now, if you're looking at this right now, you actually can't tell that that's not ANSI SQL. It could be. There's nothing about this that syntactically is not ANSI SQL, but this is actually a query from a language called K-SQL. And this is going to ingest an input topic. That topic happens to be called ratings, and join it to a table called movies, and then emit the joined and computed aggregate result to a topic called movie ratings. And this is just going to run. Every time a message shows up, this query runs, produces a result. There's no batching, there's no latency. This is like the lowest latency way to get this analysis done. And this is great. Rachel's going to talk later about what happens when I have ad hoc questions and I have an analyst who wants to sit down and analyze data in a Kafka topic in ad hoc ways. But that's not what K-SQL is. K-SQL is when that analyst has produced a query and we want this query to run all the time and I always know what it's going to be. You can do that in K-SQL. And that runs on, again, an infrastructure of its own, always consuming from input topics, always producing to output topics. It's a different kind of query that runs continuously. We're not trained to think of queries that way, but that's how K-SQL works. It's pretty neat. Briefly, let's talk about what kind of software architecture this implies. All right, and I'm going to show you, I'm sure, just given the number of people who are in the live version of this presentation right now, or if you're listening to it later, there's somebody who works in retail, right? And I'm going to show you a not particularly realistic microservices architecture that's kind of suggested by retail. And I'm sure if you work in retail, you'll find this positively adorable, but hey, play along. Suppose there's some web front end, right? And somebody clicks submit on an order, and my React front end throws a little blob of JSON at a REST endpoint on an order service, right? What does that order service do? Well, not much. Let's say it validates the object. It says that looks like a good order. What has to happen with that order? Well, this service doesn't need to care about that. It just needs to produce that validated order as an event to a topic. Now, what must be done with that topic? A lot of things, but minimum viable product, let's say we need to ship it. All right, so now we have a shipping service that doesn't take its output from any user interface out on the web or in a mobile app, but merely consumes messages from that order's topic. Every time a new validated order is produced, shipping service says, hey, folks, wake up, there's a customer, let me do that, and now I will do whatever interface is with the warehouse. Maybe it's some mainframe or some unpleasant system that someone has to write code to talk to. That's okay. That shipping service consumes that message and does that, and now the warehouse knows it has things to do. Obviously, that's not a complete story though, because for example, the shipping service is going to need an address, and maybe that address doesn't come with the order object. There's probably though a way for a user, again with some nice web front end, to talk to some REST endpoint on a service that maintains user data. So separately, prior to this order being placed, the user set up her profile, and when that user entered her shipping address and clicked save, well, that user's service didn't write that to what we'd call database, just produces that to a topic. And now that topic is like a change log of users. Remember the key value pair thing. The key is going to be the ID of the user, let's say. The value is that user record. And the Kafka Streams API lets us kind of materialize that change log into a little internal key value pair, like an internal hash table that's scalable. I'm eliding plenty of details here, but that internal hash table is horizontally scalable. Everything is fine for very big sets of users. But that user service now can do key lookups on that same thing. Also, shipping, who needs that same data, can materialize that same view. We have a log of immutable events. So making a copy of that in another service doesn't cause any data integrity problems. We're able to share data between services. And this is a classical microservices problem, right? Even in my toy example here, orders, shipping, users, everybody gets that breakdown. And it's easy to decompose them functionally, but the data doesn't play along with us, right? Shipping needs orders and it needs users. They need to share data, which is a classical problem in building a microservices estate. So this kind of Kafka integrated microservices story gives us a pretty clean way to do that, both to write event-driven microservices, which is certainly the trend, and to have a clean story for sharing data when we need to. We will talk in a little bit. Rachel is going to tell us how this can work. She needs to tell us what Druid is, but there's so much more that needs to happen, okay? Operating this system, making orders happen, needs to be a thing. We need to do this with microservices and have them all integrate reactively through a message substrate. But we're also going to need to do analysis of these things. I mean, what kind of analysis is going to be done of orders, users, every other of the 36 topics that are going to be a part of the system before it's real? That data is going to go into Druid, and we'll expose that through some product analytics front end. And that's the thing that with Rachel's part of the presentation in hand, we will be equipped to show you.
Fantastic. Thanks so much, Lisa and Tim, for inviting me to talk a little bit about Druid. It seems like we have a ripe audience. So we're going to talk a little bit about how Druid fits into this architecture and the microservices architecture, and what in the world it is and why you would use it. So I'm going to start back to where Tim left off. So he talked a little bit about K-Sequel and being able to do, write queries on the stream, which is phenomenal. So if we're looking back at that orders topic, and you wanted to know information about average orders per day, or you wanted to get a count or create some sort of alerting mechanism when you hit a certain threshold, or there was some type of inventory information that needed to know, K-Sequel is a perfect solution for that. So that's the first part of any analytics pipeline, is getting quick hits of information about your data. And we're gonna step back into the time machine a little bit and learn about where all this came from. But there's definitely a need of taking that order data and looking at it over time, and then being able to compare it, to aggregate it, to see how our orders are comparing to last month. How does it affect to a digital advertising promotion that we did down the line? And this is where Druid comes in. So it will actually read data natively from a Kafka topic and put it into a distributed system that has been designed for OLAP style queries, so for ad hoc interactions. But we live in a world where that order web UI is a beautiful React application, And our users, our analytics users, or our back office users want an interface that's just like that. They want something snappy. They want something that is going to give them answers that allows them to explore the data like they do the front end applications. So that is the type of application that Druid enables. It enables interactive analytic applications that are based on event data. So what the heck is Apache Druid and why should I care? So we're gonna, Tim and I are gonna jump back in a time machine, and we're gonna go back and try to find where Druid came from and what's the whole big idea. Oh wait, that's a little bit too far back. That's still a Druid, but not exactly where I wanna go to. Yeah, I wanna go to about here, to about the 90s. So we had the Spice Girls, you know, the internet had just been invented by Al Gore. It's a great time to be alive. And the traditional way that organizations did any type of analytics or shared data between applications was with an architecture that looked a lot like this. This was developed in the 90s. Ralph Kimball and Bill Inman were the pioneers, and they advocated taking data from your data sources, from, at that time, maybe a relational database that held your order information and your user information, and you did a big ETL job, you know, wrote some type of code for that, and then dumped it into another database, a single server. We called it a data warehouse or a data mart. It was schema on write. So you had to figure out what questions you wanted to ask and how people were going to access that data, and merged your different data sources together into these ETL jobs and dump it into a data warehouse. And from all accounts, in my experience with this, it took about 18 to 24 months for any reasonable system like this to be built. If you want to think about what you were doing 18 to 24 months ago, any questions you might have had about your life or about even your business probably will have changed by now. So these data warehousing architectures were great, and I built a lot of them, but they did have some downfalls. And the downfalls happened a lot in the 2000s when St. Jobs of Apple came and gave us the wonderful world of mobile applications. And all of a sudden, there's a lot more data, and it's coming in at velocity that nobody really expected. So that old 18 to 24 months where you could do a lot of batch processing and take data into a single database, that was no longer going to be sufficient. So we had a rise of NoSQL databases like MongoDB or Cassandra that helped companies create these applications that allowed you to create orders. And then we moved into more of a microservices architecture where you didn't necessarily even need a big database platform to store all that data, or you still used relational databases. But again, we still had a lot of data, and we didn't really know what we wanted to do with it, and it was coming in too fast. We didn't have 18 months, so we're going to dump it into what we call a data lake. And that was typically HDFS or cloud, some type of Hadoop infrastructure. And I bet you a lot of people out there are currently in this world. Most organizations that I speak to right now have some type of data lake out there. And the data lake was great because it was no longer schema on write, it's schema on read. So you could just throw your data in there and say, right, I'm going to take this data out, and instead of doing ETL, we're going to do ELT, so extract, load, and transform, with some great MapReduce jobs or Hive or lots of different technologies out there, and be able to pull the data out of Hadoop and then use it for our reporter and our analytics down the line. Also, this works for a lot of companies. It does not handle, though, the now, the architectures that Tim just talked about in terms of streaming platforms, and data that is coming in from a number of different applications. That architecture no longer works for that. Yeah, I mean, yeah, you could pull your Kafka data into Hadoop. That works fine, but they're not designed for it. And then this is where Druid comes in. Druid was designed from the get-go to take data natively from a Kafka stream or from a file system like S3 or HDFS and combined it together into a single database to be doing true OLAP ad hoc analytics. So some of the issues that we had in the past of having to know our queries up front and design our schema for that are no longer necessary. The batch data and taking 18 to 24 months to integrate data together, that's no longer necessary. And so this is the next generation of these analytics platforms. So why was it started? What was the issue that that caused somebody to say, hey, I need to make a new system here? Not just a great idea, it was actually a problem. And the problem that the developers originally of Druid had is they wanted to create these interactive applications for back-end type of analytics. They had log data, and then specifically for Druid's case, it came from digital advertising. So impressions and clicks and being able to make decisions about what ad to show and when required a full-time stream of data, so a large scale. The queries needed to come back in sub-seconds because the quicker you showed and you made a decision about what ad to show, the better off you were going to get conversion. The complexity of the data was very high because it was very, very fine grain. There was a very high dimensionality of the data, so tens to hundreds of dimensions, but but the cardinality of those dimensions were very high as well. Lots of different users, multi-tenant applications, and the data was coming in all the time. It was relentless. At the time, so this was about 5 years ago, the traditional ways of managing that were to cobble together a solution with from different places. So you could be using a search platform like Elk or Elasticsearch, or you could use an OLAP style database like Vertica, or you might want to go into the time series world and use one of the time series databases. But the problem was not each one of them was missing a component. So the search platforms did not have the ability to do OLAP queries. You could search for your data, but as soon as you wanted to do any sort of slice and dice and you wanted to hand this to analysts, they became very difficult. The OLAP systems provided you that, but they didn't have that real-time system. They weren't designed for Kafka or for streaming platforms. Those were sort of bolt-ons. And the time series databases generally can't scale past a single server, and were designed much more for transaction processing in a single time frame. So they actually, so the authors of Druid, who are actually the founders of Imply, my employer, who said, all right, let's take some of these best ideas. So let's do streaming data from search, let's do ad hoc queries from OLAP, and let's give it a time-based component so we can do time series style analysis. And they built a system that we now call Apache Druid. Apache Druid is a high-performance analytics database for event-driven data. The types of use cases that we see customers using, about 40% from a recent poll are using this for digital advertising. So publishers, advertisers, and exchanges all use Druid. User event analytics, so click streams for cable companies, for set-top box, quality of service for any types of video ads. Those are real-life use cases of using Druid. That's another 40%. About 10% use it for network telemetry, so taking data off of router logs and being able to do true ad hoc analysis on that network router data for telemetry. Or just applications that have lots and lots of data. IoT is another common use case. Product analytics at very large retailers or very large web presences, or using it for fraud detection. So if you're looking for financial services, a number of customers that are doing this, just look at fraud as it's happening and be able to compare it based on what's been going on in the past. Have to have a gratuitous customer quote. Yahoo is pretty well known for having a lot of data, and they are very active Druid users with billions of events and getting queries back under a second. So, back to our diagram that Tim had shown us before. So hopefully now I've shown you why Druid is the right choice for doing any type of product analytics when you do have data that is coming in from some type of Kafka topic where it's being shared. So rather than trying to create a centralized system, you can use Kafka as your central nervous system to feed your different microservices or feed your different applications. But then as the time comes where you need to be doing real analytics on what's going on with that data over a long period of time, that's where Druid comes in. So they always ask me, let's do a demo. And so what I thought I would show you today is of the newest, freshest version of Druid, and it's this is actually in pre-release right now, and it has a new data loading wizard. So this is the Druid console that you have access to, and this is a live demo, so bear with me.
So everyone, just stand back.
Right. I'm going to be doing real query or real stuff now.
Yes.
Okay. So first off, I need some Bootstrap servers. So I'm going to go ahead and paste in my my Kafka servers.
So those are links to a broker, the address of a broker or two in the Kafka cluster, right?
That's exactly right. And this is the topic that I want to take the data out of. So Timmy did a great job of explaining topics earlier. So that's all you need. You just need to know
what kind of data is in that topic, Rachel.
This particular topic is Wikipedia data. So
I like it.
It's publicly available. I'm not going to get into any trouble by showing this to people.
That's one of the great things about it, is that it's publicly available and everybody knows what Wikipedia is. And look at all of that JSON. Make it stop.
Right, and we're looking at the start of the stream, but we can also look at the end of the stream and take a look at the and preview out the data. So next, after we preview the data, the next thing we were going to want to do is, because this looks like data, but let's go ahead and parse it out.
Yeah, I have no understanding. What?
Yeah, look, we have columns. Isn't that exciting?
Okay.
We have channels and city names. Yeah, I didn't tell it. It just sort of figured it out, which is one of the fabulous ways that JSON has made our lives easier.
This does not make me mad at all. If it does make you mad and you're listening, let us know in the chat. But this is pretty cool.
And I will ignore you. I mean, I will address it right away. Sometimes this is obviously a very simple style data set. There are more complex ones out there. I just had somebody ask me the other day, well, what about we have XML embedded into our JSON? And I'm like, you're living dangerously. But we can actually flatten out columns.
Even with mixed formats like that?
Yep.
Okay. What if I have EDI in my XML in my JSON? No, sorry, I'll stop. Go on.
All right, so now let's talk about time, because time's important. We can use the timestamp format and change where it's looking from. But this is really important in terms of how Druid functions. We talked about partitioning data in Kafka. There's a similar concept in Druid, and it is based on time, because honestly, what analytics query out there is not going to have some type of time component. It might be all time, but most likely it's going to be narrowed down to a certain window. All right, so we've extracted our data. Now we're going to transform it. And this is where we can add some column transforms. We can perform simple transforms. If you want to do more complex ones, I would highly recommend using KSQL or some other Kafka-y thing for doing more complex transform before you even put it into the topic. But if you need to do some simple stuff, you can add it here. Same thing for filters. We can filter out on a particular column or add a global filter. This might be some way of dealing with GDPR compliance, or this may be just a way of separating out data into tenants, or even separating out data that you're not going to want.
And a brief thought on that, Rachel. So at the point, if you're doing a transform or a filter when you are here, like you haven't thought of it yet, and now here you are in the Druid interface, do it here. But there might be, like Rachel said, there might be like a PCI compliance thing or a GDPR compliance thing where you can't make a certain stream of data even visible to analysts. Well, then you get that transformation done in a topic. You have the input topic, you transform it into some other topic, and you make that topic available to Druid. So sometimes it's appropriate to get these things done completely on the Kafka Confluent side, but sometimes you don't know that you need to do that, right? You're slicing and dicing data, and so at this point, you do the transform and the filter, and the being able to do that real time in Druid is indispensable. You don't have to go back and ask a developer to write a KSQL query or Streams app to do that transformation.
Exactly. This is very much a analyst friendly sort of system where you don't need a data engineer to be doing all of your work for you. You can do a lot of it here. Things that you will need a data engineer for, and you will need to have to do in Kafka is if you want to merge two very distinct data sources. So one of the examples that Tim gave earlier was the orders data and the users data. I'd probably want to merge those together into a single Kafka topic. Another way that we could handle that into Druid is by doing a join within Druid itself by using the lookup command, and maybe taking the orders data that would be coming in from a Kafka stream and the users data that might be coming from a Kafka stream, or maybe it's coming in from a Hadoop database, and using that as a lookup to enhance the data at query time. So there's a few different ways that you can I don't know, burn that bridge, I guess. So Druid natively talks about dimensions and metrics because this is how analysts talk about their data. So just very quick, the idea of a dimension is what you're going to slice and dice on. So what are the things that are going to be in your where clause if you're talking SQL, or what are the, how are you going to want to slice out your data? Metrics, on the other hand, are the pieces of data that you're interested in tracking and interested in seeing. And Druid will usually determine these on their own, but you can add them or you can explicitly state them. There's two other really important concepts on this screen that I want to talk about. One is explicitly specified dimension list. And what that means is, do you want to have a very strict schema for this particular piece of data for this particular table? And I like to say that Druid is schema flexible because you can explicitly specify it, but you can also turn this off, which means as new data is added to your Kafka topic, Druid will actually just add these as new columns to the end of your table. Druid is a columnar-based database, so this is virtually free to do. There's no need, none of the old world that makes crusty old RDB, relational database people like me shudder. Alter table, add column, that was like a stop the world sort of event. It's seamless here. So it's a schema flexible environment. The other concept that's really important is roll up. And that's also an analytics trick to help make your data more relevant and your queries faster. Druid will actually aggregate data as much as it possibly can on ingest. If you specify a roll-up, so for here, we're saying we want query granularity to be an hour, it will roll up the data the hour, but you can take it down to the minute, the second, the day. This is completely customizable. Things like you may not want to see data at the millisecond level at all times, so you may want to roll that up to a second level or maybe a minute level. But that is a good way of compressing data and making your queries faster. Typically, I will say that raw data compresses to about a 10-to-1 ratio in Druid. That's a good starting place. Of course, your mileage may vary, and you can ingest raw data into Druid. Another trick of the trade that we have is theta sketches and other ways of approximating data. So if you want to make your count distincts or your counts go a lot faster, you can use approximate algorithms for that. But you also don't have to, and you can also just have, get exact results as well. So some pretty cool technology that's built into Druid on that. Of course, this is we all need a screen about partitioning and tuning our data. This gets very much into the weeds of how Druid works. For the most part, this particular interface is going to provide the best guess. But if you want more information about that, this is available in documentation, in numerous blog posts. Please contact me if you want some more information on how to tune Druid. Last but not least is hey, this is our configuration. How do you want to publish it? You can actually just execute this directly to your Druid cluster. What it's going to do is creates a JSON spec. Up until the availability of this UI, you would have to write this congestion spec yourself, which is kind of like doing your taxes by hand. This wizard is much more like using TurboTax or QuickBooks or H&R Block to build it for you. Is that a question that I had heard from you, Tim?
No, I shuffled in my chair.
Got it.
I felt a little attacked about the thing about doing my own taxes, but I'm going to take your advice.
Hey, you're welcome to. You and that 1040 can have
you are here for me.
Anyway, so that I think we're actually coming up straight to time. That was all that I had. What did I miss? What else could I answer for you, Tim, before we open it up to the audience?
Nothing, actually. I think this is fantastic. And I have this super secret view of some of the questions that the audience have asked. And I'm chomping at the bit to answer those.
All right, let's go for it.
All right, well, thank you so much, Rachel, and thank you, Tim. Before we get to the Q&A, I wanted to do a quick plug for Kafka Summit. It's coming up. It's in San Francisco, September 30 to October the 1st. And as a thank you for attending today, we are offering a discount for you to attend. Just register for Kafka Summit and you can use a promo code. And I think we're going to display that KS19 on line 25. So register for Kafka Summit. And now I'm going to get to the questions and answers. We have quite a few that have come in. So unfortunately, we won't be able to get to all of them, but we'll do our best. The first one.
Can I put a quick plug in? I think both Tim and I are speaking at Kafka Summit in San Francisco.
Yes, Rachel Pedreschi is speaking at Kafka Summit, ladies and gentlemen.
Excellent.
Use the discount code, sign up. I can't help you do that. I can only tell you that it's a thing you should do for yourself. I'm not speaking, Rachel. I am emceeing, and I was in charge of the program committee, so and the overall program. So I can say it's pretty awesome. Obviously, Rachel's in it, so it must be good. You really should. I think it's just self-care for you to sign up for Kafka Summit. You owe it to yourself.
Awesome.
That's all I can. I'll probably say it again by the time we're done.
Oh, there it is. There's the plug. So we'll just leave that up so that you can get that code and register. And I'll go ahead and read off some of those questions that have come in. Let's take a look at those. I think this first one is for Tim. How is using Kafka Connect different than directly using Kafka Client?
Great question. So anything Kafka Connect does, you can do with the Kafka Client library, but you have to. And there is deceptively more complexity in there than you think. So number one, whatever it is you're interfacing to, or a relational database, Elastic, S3, well, then you have to do that. You have to write that code, and there are going to be edge cases. You're going to have to test it. You're going to have to feed it and care for it. So that's the thing. Also, scaling of the connectors. Connect is a scalable framework. I can deploy a single Connect server. I can scale that out elastically to a cluster of 5 of them, and my Connect workers and tasks will rebalance among that cluster. All that stuff is there. You don't want to build that. So it seems simple on the face of it, but as my friend and software architect Admiral Akbar says, that's a trap. You don't want to write that yourself. So there's a lot more than you think.
Thank you. The next question is also about Kafka and KSQL. And can I unit test KSQL? And how do I do that?
Sure, sorta. So if you think about it, it is really the kind of thing that one integration tests. If you see that remember that diagram where I had the KSQL server and it's consuming from a topic and producing to a topic, it's, you unit test methods, and this query that runs in an engine, you probably integration test. If you insist and you would like to write an automated test for KSQL using JUnit, it's not documented, it's not supported, the skids are not terribly greased, but I'm going to say a couple of things. There's a class called KSQL Engine that you can look at in the KSQL code. It's in the Confluent Inc. /KSQL repo on GitHub. KSQL Engine is a thing that you can use to embed KSQL in your test, and then a thing called Test Topology Driver, which is a part of Apache Kafka for writing unit tests around Kafka Topics. Explore those things. I regret that I don't have any sample code that I can point you to that makes this happen in a JUnit test, but you could make it happen if you really hate the idea of just integration testing it.
Okay, the next question is, what transforms are needed to move data from Kafka to Druid?
Rachel, I'm going to start, and then you tell me what I did wrong. How's that?
Perfect.
Okay. In general, none, right? You have events in Kafka, and Druid has its own ingest system. So it's funny, I just talked about Kafka Connect, and you're probably thinking, oh, that sounds like a Kafka connector. Druid has its own way of doing that ingest and consuming directly from Kafka Topics. And one might require any number of transforms depending on what you're doing, but it's not like there is some fixed, you have to do this to the data before it goes into Druid. Rachel, is that fair?
That is 100% accurate. So that was a raw Kafka topic that I picked up. That's exactly how you would pick up from your Kafka topic. Nothing else you need to do. Now, remember, the data that's in your Kafka topic will end up in your Druid database. So that you're only going to get as good of data as that you have.
Yes, and you'll have all of the data that's in the topic. Maybe that's bad, right? So, you might have to do lots of transformations, but there is no, one must ABC before it works.
Yeah, and Druid does actually keep with the exactly once semantics as well.
Ah, beautiful.
So you won't lose any of that.
Okay, the next question also looks like for Rachel is, how do you differentiate Druid from Snowflake?
That's a great question too. So I like, so Snowflake is I like to call it a data warehouse appliance for the cloud. There's a long history of appliances being used for data warehousing and data marts, starting with Teradata and going to Netezza and Greenplum, where you were tying directly your hardware and basically your compute with your data. And Snowflake was the first database to say, right, well, we're going to create a database that is built on the cloud that actually takes advantage of separating compute and data, and gives you sort of a turnkey solution for doing data warehouse architectures. And it does support star schemas and very, very traditional sort of data warehousing world. So it fits into that kind of that middle ground that I talked about, where data lakes were sort of coming up. This is sort of the middle between old school data warehouses and these data lakes. And it works great. Snowflake is an awesome system for doing traditional data warehouse workloads. Druid is much more of a data mart or a single subject data mart. So a single subject data warehouse is what a data mart is usually defined as. And it is also cloud native, but it was cloud native because it had to be, because it was developed after the cloud was a thing. And it is for low latency queries, OLAP style queries where you need to slice and dice, you need to create an interactive application. It's not purposely suited for more of your data warehouse where you're bringing data in from batch and you're doing more of the 5 to 10 second level queries.
Thank you. This next question is for Tim. The idea of using Kafka-backed microservices would eliminate the need for one database microservice architecture. Is that correct?
Yes, if I understand the question correctly, having microservices share a database, integrate through a database has, I think, emerged as an anti-pattern, right? We kind of started building microservices that way 5-10 years ago, and everybody has realized bad plan. And so this is a way of getting away from that. What most folks have been doing more successfully has been having synchronous RPC calls between microservices. That works better, but there are also some problems with that the Kafka and messaging integration between services gets you around. So I think the answer is yes, you're hearing me correctly.
Okay, thank you. For the Druid demo being shown, where is the compute happening for applying the transform or filter? Did that make sense?
Yeah, it does. It's happening within Druid itself. So Druid has a number of different processes that can be spread out onto different types of machines. But those transform processes will be happening on the ingestion tasks.
Okay, and does this integrate with Avro and the Confluent schema registry?
Ooh, by this, I assume you mean Druid. Rachel, is there any integration there?
There's a integration with Avro for sure.
Okay. So that means that Druid is going to be happy to ingest Avro messages, and not sure if those schemas are coming from Avro, but we will follow up on that.
The next question is, where is the analytics UI for Druid? How do we query and interact with the data structure just created in the demo?
Great question. So that UI that I just showed you does have a SQL interface. There are other interfaces designed for Druid, specifically Imply. The Imply UI is an interactive slice and dice UI that is there to create those interactive applications, and be happy to talk more about that. Other ones that are out there are Superset. That's not specifically for Druid, but is used fairly often with Druid. And then clients use other ones like Excel, Tableau, Looker.
Okay, thank you. The next one looks like for Tim. How do you handle Kafka Topics with expiration?
So I think that's a question about what we call the retention policy, or how long we would like data to live in a topic, and that's a little bit of metadata you set on the topic. You tell the topic by default, say it's 7 days. You can change that global default, or you can say this topic, I want your retention period to be 2 years or an hour or whatever. That's just a little knob that you have to set on the topic.
Thank you. The next one looks like it's for Rachel. Apache Druid is open source, and Imply is another application or framework that's based on Druid but with more features. Is that correct?
That is very correct. So Imply as a company was started by the original authors of Druid, and we provide support and services around the Apache Druid database. The version of Druid that you just saw actually came from Imply and is the latest and greatest, not been released into Apache quite yet. So Imply engineers actually do create new Druid features and then donate them to open source. The other portions of the Imply application include security integrations with LDAP, Okta, and Kerberos, that pivot UI that I spoke about earlier, a cluster manager, and also a managed service in AWS.
Great. Thank you, Rachel, and thank you, Tim. It's about time to wrap up. The slides and the recording are available online, but we will also send them to you in a follow-up email. Thank you so much for joining us, and we'll see you next time.